If you're thinking of having solar and battery storage installed at your home, you might be wondering what all the key components are. So things like inverters, batteries, solar panels, what are they and what do they do? And where should you really be spending your hard-earned money when you're thinking of purchasing this? Well, today's video is going to be breaking down what these components are, what they do in a real jargon-free manner, so that if you have someone coming over to your home to quote for solar panels and battery storage, you know the right key questions to ask them so you don't waste any money. Before we kick off with this video, I just wanted to clarify something that I've said in the video that doesn't come across as particularly clear. I've misdescribed something. I firmly believe in owning it when you make an error. I've described battery storage, which you have a battery and it's stored in kilowatt hours. I've described it as kilowatts, and I've used these terms interchangeably when that's not the correct way of doing things. Essentially, to give you a brief description before we get into the video, if you use energy, so essentially think of energy as a flow rate, like water through a pipe, that's done in kilowatts. When you store energy, it's done in kilowatt hours. And as I say, I've mentioned storage as if it's kilowatts, but think of kilowatt hours as the amount that's stored, i.e. water stored in a barrel, and think of kilowatts as flow rate. Let's return to the video. So first off, let's just cap over what these components are behind me. So we've got the solar panels, which are up on the roof. Now, clearly I don't have solar panels with me right at this minute in time, but what we also then have is the inverter. So this takes the DC power that's on the roof, and this is going to convert the power to alternating current, which is the electricity we use in all of our home appliances. So when you boil the kettle, that uses an alternating current. And if there's an excess of energy, it can store it into the battery. So if you're cooking your tea later on, this energy can be drawn up from a demand that's been generated in the middle of the day, saving you buying expensive energy at night. We then have a couple of ancillary parts as well. So we've got isolators. So in the event of an emergency, we can turn these off. Or more likely, if someone's just physically working on the system, say an electrician comes to replace a light, that they can turn this off safely. Because if you think about it, instead of energy being drawn in from the grid, you've now got a secondary supply to your electrical system. This next component is a fuse board. Now, sometimes we're able to utilize the existing fuse board in your home, or sometimes you might need a second one or another one in addition to like what we've got here. Why do you need these? Ultimately, they've got protective devices that are protecting you as an end user and protecting the components of your solar system. What is this little box here? Now this is controlling optimizers up on my roof. An optimizer sits on the back of a solar panel and helps assist with shading, not cloud coverage or a little bit of trees. I'm talking more about like a chimney stack that's going to really move, or another property, or a much bigger tree that shades a great big part of your solar array at this point in time. This is where optimizers come in. This clicks onto the back of a solar panel and this regulates what this solar panel is doing. So as this solar panel tracks into this shade, that panel's now sat in the shade. That panel can essentially turn itself off, disconnect itself from the circuit using electronics. As the chimney stack moves on to the next solar panel, that solar panel can fire itself back up again, and this solar panel will turn itself on. So if you've got really heavy tree coverage, if for example in the winter it's completely covered, then optimizers may well be a great key component. So what is this black box and what does it do? So this is the communication device. It's called a Cloud Connect device. So this is talking and communicating with these optimizers at any point in time. I then have a mobile phone app and I can essentially see what each of the solar panels is doing at any point in time. So I can see what their generation's been over the course of a day. I can see what they're generating right now. So I can then see what the effect of that shading is having at any point in time on my solar panels. If in the future we had a failure, a problem, say the aerial fell down and broke a solar panel, you would also be able to see where that failure sits and lies. So from a maintenance perspective, it's really easy to get up to the right solar panel that's at fault. If you've been Googling inverters, you probably come across four main types: a string inverter, a hybrid inverter, an AC coupled inverter, and an all-in-one inverter. Confusing, right? Well, let's just kind of break down those four key types and what they might mean to you. So the first one is a string inverter. These are the very simple traditional style of inverters, where the energy gets generated on the roof, it converts energy, and you can then either use that energy or it gets exported out the grid. You've got no facility to be able to store that energy. Most people aren't tending to go for these days unless it's simply just to improve your energy performance rating. So the more common type is the hybrid inverter, which is what I've got next to me here. It gets the name hybrid inverter because it can both take energy from the sun and deliver it directly into the home, but it can also store this energy up for usage later. The next type is a thing called AC coupled. Now this is brilliant for if you've already got a solar system. Let's say you had a solar system fitted a couple of years ago, or if you had a system that was installed under the existing feed-in tariff and you don't want to sacrifice any of those feed-in tariff payments. The AC coupled will leave the existing inverter alone. It tracks what your existing solar generation does, gives you this information on an app, and can store and charge and discharge the energy in real time. Essentially, you have two inverters both working in tandem. And the next one is a thing called all-in-one. It has a very similar system to the hybrid, except for all the components actually physically built into the same unit. So a classic one for this is the Tesla Powerwall 3 that's just come out and hit shelves. That's a classic example of the all-in-one, where it has this solar inverter and battery storage all built into one compact unit. There is, ultimately from a performance perspective, there's a big difference between the Powerwall 3 and this one that I've got behind me, but ultimately it's very similar key componentry, it's just built into a neater, smaller, more compact model. The money is made in a solar system by storing the energy to be able to use and utilize that later on. So what that basically means is on a sunny day, energy's been generated, inverted into the battery. This inverted energy gets called up for demand to be able to cook your tea. Thus, you don't draw any energy in from the national grid. Now, one of the second aspects to a solar system, and one of the other brilliant things that an inverter can do as well, as long as you buy the right technology, and it's really important that you check in on this with your installer, is the ability for the inverter to buy cheap nighttime electricity. So if you have an electric car, or if you just have battery storage, there are tariffs now available where effectively you can buy cheap energy in from the national grid at night, put that and store that inside of the battery, and then later on in the evening you're drawing up this cheap energy that you purchased at night and delivering that into your home instead. And what that often means is, particularly with the likes of Octopus Intelligent Go, which is an EV rate that I'm on 7 pence as a night rate. So if you're thinking you're paying 27, 28 pence for your day rate, it's a massive reduction. You're talking 60 to 70% on average by way of a reduction in the winter time. One of the next things I wanted to come on to was the size of battery that you should go for. It's a really interesting conundrum because you'll be thrown all kilowatts at you, 5 kilowatts, 6 kilowatts, I think you should have 20 kilowatts. Ultimately, installers are incentivized to give you the biggest possible battery you could install. But actually, it's going to be dictated by the amount of energy consumption that you use each year. So my personal suggestion would be, draw out one of the bills, sweep it off from underneath the desk and find out how much you use every single year. Now, for the purpose of this explanation, let's say we use 3,650 kilowatts per year on an annual basis. This normally tells you in the top right-hand corner of your bill your estimated annual use, or get a month for use and multiply it by 12. What we can then do is divide that by 365. So in this scenario, I use 10 kilowatts of energy per day. If you're doing battery only, because it is possible to install one of these systems with just a battery, then in that scenario you want to be looking at your day's worth of energy usage and buying the same size of battery pretty much as your average daily usage. We're looking on weighted average basis. If you have one day that spikes a little bit high, don't worry about it. Get your annual, divide it by, we're looking for the average. But if you've got a solar system, you'll almost always generate energy every single day, other than if your solar panels are covered in snow, even in the heart of winter. So if I've got a 10 panel system, some of the worst days of generation I'll get is 1 or 2 kilowatts. Well, at that point in time, that's about 20% of that usage. So I've gone down to 8 kilowatts a day that I now need to find storage for. But remember, you're now on a cheap night rate as well, because you're buying this energy in for cheap within the battery. And those night rates often last for 5 or 6 hours, with flux only lasts 3, so this equation could change. So now I've got 5 or 6 hours, well, that's another 25% of my day usage, 2.5 kilowatts. So at that point, I actually only need a battery that's about 6 kilowatts in capacity to be able to buy enough on the cheap night rate to be able to last the full day with a little touch of solar and a little touch of that cheap night rate, thus bringing the cost of your initial installation right down. The other good thing to remember is with batteries, you can expand them. You don't have to buy all the batteries all in one go. Make sure you've got a manufacturer that can do this, of course. But with a Give Energy battery, which is the one behind me, we can buy them in smaller denominations. The smallest denomination is a 2.6 kilowatt battery. It then goes up to a 5.12 kilowatt battery. And then you've got this big one like the one behind me, which is a 9.5 kilowatt battery. So in that point in time, if say hypothetically speaking, you only bought 5 and at a later date you needed another 5, well actually, it's a no-brainer. You could start with the 5 and you could always add a little bit more at a later date. Questions to ask your installer about battery storage. So one of the things that most people don't realize is that most battery storage have a cycle limitation. Think of this a little bit like a car warranty. Car warranties might have 7 years, 100,000 miles, and it works the same way with your battery. Now this Give Energy battery that I've got behind me has a 12-year unlimited cycles warranty. What that basically means is we can charge and discharge the battery as many times as we need to within that 12-year period. Some batteries only come with a limitation. They might have a 10-year warranty, but there's a cycle limitation. Think of this in your mind, that cycle number 1 could be charging up at night. You cook your breakfast in the morning, solar comes out, battery starts to charge again, that could be cycle number 2. So you might run as many as say 700 or 800 cycles in the course of a year. Now, if you're running this many cycles and your battery has a 5,000 cycle limitation, it may well mean that the number of cycles you're running might not match the length of warranty that you're in for. If you're making the use of a demand flexibility service, or if you're tracking with a thing called an open API, but what that basically enables you to do is access these grid prices. As the grid price changes, you can get a battery and inverter to map to those cheap prices. So let's cheap in 2 o'clock in the afternoon, or it's expensive at some other time. Your battery can import and export flexibly based upon the price on the grid. So something to bear in mind is there can often be cycle limitations. For example, with Give Energy, if you read their terms and conditions, it's a 10 megawatt hour, so 10,000 kilowatts per kilowatt of battery. Sounds confusing. So essentially you get 95 megawatts worth of charge, 95,000 kilowatts worth of throughput in the battery before the warranty would come to an end. So that can shorten the length of the 12-year unlimited cycles warranty on a Give Energy battery. And this is way more prevalent with other manufacturers as well. So do have a quick look at the small print, because if you're thinking of making the most of some of these systems and schemes, they do interlock with one another. Appreciate that might be a little bit complicated, but I thought it was really important to share that with you. If you have any questions of your own, don't forget to stick them in the comments and I'll do my best to get back to you. Something else to give a bit of thought towards is a thing called depth of discharge, or DOD. With this battery behind me, it has a 100% DOD, depth of discharge. What that means is the full 9.5 kilowatts can be accessed and used. Now, for the purpose of this equation, imagine we now have a 10 kilowatt battery that's got an 80% DOD. What that actually means is it is 10 kilowatts worth of battery cells, but you can only use and utilize 8 kilowatts of the actual battery storage that goes behind it. So in your mind, think of this at this point in time, someone's selling you a 10 kilowatt battery, but you're actually only getting 8. So that's something else you need to consider when asking your installer about battery storage. Now, if you're enjoying this content so far and you're finding it really informative, please don't forget to like and subscribe to this channel. It means a massive amount to us and helps us bring great content like this to you. Another question I get often asked is, I've seen a really cheap price. It's got one brand of inverter and a different brand of battery manufacturer. Now, I'll come at this from a perspective of protecting your investment. You're thinking of spending thousands of pounds on this. My personal recommendation is always making sure that the inverter and the battery are all from the same brand and manufacturer. Why? My personal experience from this is when you look to try and cut cost or cut a corner in some way, shape or later on down the line, if you come to claim on that warranty, let's say the battery had gone wrong at this point in time, the battery manufacturer would blame the inverter manufacturer blames the battery manufacturer, and you end up a little bit like piggy in the middle when it comes to claiming on your warranty. So it's really important, in my opinion, to get the inverter and battery brand to be the same cohesive brand, so if anything goes wrong, you're covered. Inside, outside, where should you be installing a piece of battery storage? Is it okay to put it up in an attic? Such a common question I really get. My personal recommendation would be not to place battery storage up in the attic. It's very awkward, and actually If you've got an inverter already in your attic, I'm going to circle back if you're thinking of adding battery storage in a second. This is on the basis it's a fresh and new install. My personal recommendation and the best practice recommendations is to be either installing them outside in a garage like we're here that's separate from the home, is to be installing them at least 1 meter away from the entrance or exit to a building, or 1 meter away from a window space, or not installing them underneath stairs. These are just for fire safety precautions more than anything. If you think about it, we've got 100 kilos worth of the lithium iron phosphate battery. We don't want that to be installed anywhere where it could impede your exit in the event that you have a house fire. Now, at this point in time, you might think, oh, is it going to cause me a big fire? No, lithium iron phosphate batteries by nature are very safe. They're not the same type of battery chemistry you'll be familiar with like e-scooters or e-cigarettes, for example, where you see these big flames that are happening. Lithium iron phosphate batteries are not prone to thermal runaway, but it's just best practice to keep your home as safe as possible. My firm recommendation is you open the conversation with your installer and confirm where you're having your inverter and your battery stored. A lot of customers lean out of this as a question, assuming that their installer is just going to make the right decision, and I've come back to lots of installations where they've just done them so wrong. When it comes to installing an inverter and battery outside, not all inverters and batteries can go outside. You want to have a look at the data sheet and look for a thing called an IP rating. This stands for ingress protection. This is a protection against dust and against water. If the IP rating is high enough, for example, these have quite a nice high IP rating, then they can be stored outside the property. My suggestion, if you can, probably pop them outside, put them in a garage, get them away from a main exit, and don't put them up in an attic would be my suggestion. Which bit should you spend your money on? Some installers say, put more panels on, and other people go, put more battery storage on, spend more on the manufacturer. Which one's best? It's so confusing, so I really appreciate that. First of all, the difference between a very cheap solar panel and probably the top of the range is only about 30 or 40 quid. Prices of solar panels have been so commoditized within the industry that actually there isn't a massive disparity between the two. So loading your house up with a load of solar panels actually doesn't cost a great deal extra money. What costs the money on a roof is the railing system, somebody's time in the additional scaffolding. My personal suggestion would always be putting as many solar panels as you can possibly afford on your roof, because once you're up there installing, it's very unlikely that you're going to be revisiting this at a later date. So if you can slide an extra 2 on, it's an extra bit of generation, and it's only but going to help with return on investment, and ultimately it's going to future-proof you should your energy usage increase. What I have done is broken down the main types and styles of panels. I'm going to include a link in the description below so that you can have a good watch of that and get yourself informed on the right panels. Then you would pick your inverter that would be appropriately sized to the solar panels. If an inverter is too big and your solar system is too small, then you can have a risk of it not firing up or not firing up regularly enough. The other aspect to it is you have lots of solar panels but your inverter is too small, your inverter can throttle the amount of energy and essentially you lose out on your valuable return on your investment. We're looking for the Goldilocks effect. We're looking for that sweet spot in the middle where the solar system is appropriately sized, so roughly speaking the same size as the inverter, so if the solar system fires up and gets itself into gear, the inverter can convert all that great renewable energy for your home and either store it in the battery or export it out the grid so you get paid all important export payments. So one of the things an inverter is very dependent upon is the software. A lot of people don't think of this. They think, okay, it's just going to be great and it'll work very well. With some of the really cheap budget end of the market, they don't invest into the software or the technology at all. So they'll be very basic in their functionality, i.e. solar generates on the roof, stores it in the battery, and I can use that later. And you might be thinking, well, that's all I need it for, really. There is so much more to a solar system. One of the things you need to know is the ability to be able to charge cheap nighttime electricity at night and then use that energy throughout the course of the day. And that needs to be really simple and intuitive. If you're picking some of these cheaper budget manufacturers that are manufacturing in various different countries, then often you can be dealing with tech support in these countries as well, rather than dealing with tech support here in the UK or other parts of Europe. So with Give Energy, for example, their tech support's based in Stoke. So if we have a problem, we can call their contact centre and get a problem dealt with quite quickly and quite easily. And my suggestion, if you're going to cut costs somewhere, would be cutting the cost of the battery storage. Why? So if you look at this battery here, in order to be able to install an extra battery on this system, effectively all I've got to do is plug a lead in, mount the extra battery there, you plug the extra battery next to it, and you've doubled your capacity of the battery. It involves a couple of hours recommissioning it, setting the software up and stuff, but actually it's very simple, very straightforward to expand battery storage at ground level, as long as you thought about it in advance, saving you on that initial capital investment, and just allowing you the opportunity to try this before going whole hog and buying the biggest battery that you can get hold of. G98, G99, G100, what on earth's that all about? This directly links with the size of your inverter. So as an installer, it's very easy to install under what's called G98. What this does is limits you to 3.68 kilowatts or below. Think of it about 8 panels, something along those lines. And effectively, it's a very easy application form out to the grid. You can do a thing called fit and notify. You could say, yes, I'm going to go ahead and tomorrow we can install your solar panels, install the inverter and tell the national grid afterwards. This is by far the easiest method for the installer, but not always the best method for the end user, because this can do, like we discussed earlier, and throttle the energy. The next application is called a G99 application, essentially 3.68 kilowatts up to 50 kilowatts in application size. This, you have to do a pre-application out to the national grid. We're putting X number of solar panels, we're putting this bigger inverter, 5 kilowatts like the one behind me. Are you okay with installing this? Now, the application form is much bigger in this scenario. It takes much longer and often requires an engineer to give their input into it. My suggestion is if you're having 8 panels or more, you'd probably be thinking about G99 territory, and therefore this question would become relevant to you. G100 applications. So this is where essentially we've now submitted a G99 application out to the grid, and the national grid says, hey, you've got a 10 kilowatt inverter, but we can only limit you and you can only send out 5 kilowatts to our grid. So this is what's called a G100 application. It's a variation version of the G99. And what we can basically do is in the settings of the inverter, we can tell it, essentially you might be generating that much on the roof, but if in the event you generate it too much, we can still get the benefit of this 10 kilowatts. But if we export, so if we've got too much energy being generated, we can only send out 5 kilowatts at that point in time. It doesn't throttle you often locally or affect how many solar panels you can generate or even how much battery storage you can have. It just essentially affects the exported energy that goes out to the national grid. But again, your installer will be able to advise you based upon the size of your inverter and the application they're putting forward. You just need to know in your mind, if you're thinking of having 8 panels or more, just want to be very careful on the inverter size that they're picking for you. Think about this. You've now been restricted. A lot of people go at that point in time, well, it's not worth me having this solar system. Why would I bother? Bear in mind, when I say 5 kilowatts, it's not 5 kilowatts in total throughout the course of the year. It's 5 kilowatts at peak output at any point in time. So you could still be exporting 30, 40, 50, 60, 70 kilowatts a day. It's just going to restrict what it can do at peak out to the grid. Often won't restrict you locally, so you can still store that energy, you can still use the energy. It's just going to essentially restrict it for the grid. Why do they bother? Because often you can have older supply transformers, it can be to do with the local grid network or who else has solar on your street as well. So they do a thing called a network feasibility study. They have a look basically at what condition everything's in and then make a suggestion for the export. One thing I found personally is you can often do a little bit of haggling with them. So if they have given you a lower offer letter and you disagree with it, make sure you ask your installer to go back to them and ask for a little bit more, because quite commonly they will up it if you do ask them. Something to think about as well when it comes to this G99, G100, like the Give Energy system behind me, Powerwall by Tesla Energy, which is another product that we fit, all have the ability to be able to restrict the export. Some of the really cheap inverters simply don't have this capability, because when you're looking at cutting cost, they don't always have those facilities. I would say the mass majority of them do, but if you're thinking of a slightly bigger system, it might be something that you want to actually consider when you're considering the inverter. So I really hope that helps you. I know it's been a bit of a mammoth video, but this is a once in a lifetime purchase and I really want to make sure you get the most out of it. Please don't forget to like and subscribe to this channel if you found this really interesting. There is more videos available on our channel, and don't forget the all important video about the solar panels. There's a link in the description below. Many thanks.